My name is Max-Emilien, and I will be talking about the Dinocreta heterocantha, or the Little Barrier Island giant Weta, also known as Wetapunga. I will be specifically concentrating on what benefits it gains from its little spine on its legs, as you can see right here, and then how it serves as a defense mechanism. So my insect is endangered and lives specifically on only one island in New Zealand. As you can see, this is New Zealand, and here is that one island, and here's the island itself. There are no man-made structures besides one ranger house right here, and there are two geographical things. There's two mountains, so Mount Karakohu and Haturu. Then here's the climatogram of the year-round. So there's a significant amount of precipitation, and the temperature never drops very low. And so this means there will be vegetation year-round, and that the Little Barrier Island giant Weta will have a lot of food to eat throughout the year, meaning there will be no shortage at any point. It also uses the little spines on its feet to climb up trees to reach a lot higher into like the trees to get a better hiding spots and reach better leaves. As I mentioned, it is endangered due to one predator called the Polynesian rat, or Rattus exelan, which nearly wiped it out as it was brought in by Europeans, and it has no natural predators in the environment in this habitat. So it used to have spread to surrounding islands. However, it was wiped out there and brought back to its indigenous island. There have been some efforts by the Department of Conservation to try to bring it back to those surrounding islands. The most notable is led by the Auckland Zoo, where they raise them in captivity and then release them on these surrounding islands, because it's a whole chain of islands. Here is here's a food web. As you can see, it eats mostly plants. However, it can eat moths. This is very rare though. However, there's not been many sightings of them actually eating moths. But its main three predators are the kiwi on this island, the Polynesian rat, as I mentioned, the long-tailed cuckoo, and the saddleback. Its little protrusions that it has on its feet and legs allow it to hide in these trees to find little crevices which they can hide in. However, this is their main main way of hiding and getting against predators. This is its self-defense mechanism, which is the only one I was able to find, where they put their legs above their head in an attempt to appear larger and more ominous to the enemy, so they don't, so they run away, or that the enemies flinch and they have time to run away. However, if the enemy does not run away and tries to attack them, they will try to poke them with their little spines, so they flinch again or to just sprint away. Also, as you can see, it's on the rocks, and the little spines will allow it to hold on, as you can see here, but also to climb these rocks more efficiently and reach higher points to also reach little crevices in the rock. This is an example of it, how it eats. As you can see, it uses little protrusions in its feet right here to hold the food itself and eat it. Since this makes it so it's a lot easier for them to eat in general. And as you can see, this is a carrot, so it's a bit over-exaggerated since it's getting held by the human. But for leaves, for example, they can hold them while they eat and sit on their backs, like on the back of their butt like this. In conclusion, it has three main functions, the spines. One is self-defense, as you see here with the poking enemies in an attempt to escape. Two is hiding, so they use the little spines to scuttle across rock and to reach higher places, as well as go into trees. And the last is to collect food, as they can reach a lot higher in these trees to find plants, to find better leaves, and also climb the plants to find the more nutritious parts. However, a couple fun facts are, it is older than some dinosaurs. There have been research, they have found fossils of these animals dating back to the dinosaur age. So means it's one of the oldest insects on Earth currently, which is why the scientists have an extreme interest in it. Also, it's so big due to island gigantism. It's about this big. And so the only reason it's this big is island gigantism, as I mentioned. Island gigantism is it had no natural big predators, and its main self-defense is to look bigger, so there was no point in them not becoming bigger. So they just grew and grew and grew because they were originally the size of a cricket. And this resulted in this giant cricket that could almost bigger than people's hands. Yes.
What's the size comparison between the kiwi and your animal?
The animal's about this big, and the kiwi's like this big. So however, what I've seen is it mostly eats the eggs, because they plant their eggs underground. And since it'll look for the eggs underground, as you see, it is mostly a land predator. So it'll mostly just poke its beak. If it finds like a little crevice, it'll poke its beak and try to find these little eggs. Yes, man.
Is there anything in the future showing that it'll keep growing, or is it hit its plateau?
Yes, due to this, like the New Zealand Department of Conservation respreading it to these areas, there have been a number of successful releases. I don't remember the exact number, but so far it seems to all be doing well, and they seem to be reintegrating in this habitat where they wiped out the Polynesian rat. However, we can't really know because it is very new. It was only started in like 2000 something.